Deep Q Learning with TensorFlow. In this section, we will go through a TensorFlow overview, how to use TensorFlow in Python, and Deep Q Learning with TensorFlow in Python. TensorFlow. In this video, we will discuss TensorFlow and its components, tensors, nodes, and sessions, and we will discuss convolutional neural networks. Let's discuss the TensorFlow machine learning framework. TensorFlow is Google's open source framework and performs numerical computations using data flow graphs. TensorFlow is relatively complex to use, so it's nice to know that we have Keras as an option. Keras sits on top of TensorFlow, and you can make a fully functional neural network with just a few lines of code, making TensorFlow more usable without sacrificing the robustness offered by the system. The set of components required for TensorFlow to model its environment are tensors, nodes, and sessions. Tensors are similar to arrays and easily support higher dimensions than a data frame, minus the columns and indices, of course. You can leave the input data as tensors. The tensors are run through the nodes and steps of your model. There are different types of nodes. The nodes are where computations happen in our models, and sessions are a way of telling TensorFlow to do something with our nodes. Convolutions are linear equations. Normally, the nodes in neural networks are linked in a grid-like structure represented as matrices. With convolutional neural networks, the layers are still linked with matrix multiplication, but the matrices can be linked by these convolutions or linear equations. Each neuron in the input layer is connected to a perceptron in the hidden layer, but in a convolutional neural network, particular regions of neurons in the input layer are connected to particular perceptrons in the hidden layer. However, it's important to note that the learned weights and biases for the models stay consistent across perceptrons in a particular layer. And activation functions apply transformations to the output of each perceptron, and pooling allows us to reduce the dimensionality of the output. We discussed TensorFlow and its components, tensors, nodes, and sessions. We also did a brief introduction to convolutional neural networks.